in chemical reactions, there are two types of bond breaking or fission. First one is the heterolytic. So what is heterolytic fission? Heterolytic fission is breaking the bond, covalent bond, in such a way that the more electronegative atom will take both the electrons from the bond and will form a negative ion. And so a positive ion, that means the electron deficient atom, will also be created. Let's say we have XY and there is a covalent bond in between them. So Y, let's assume that Y is more electronegative than X. So both the electrons will be taken by Y, and now movement of the electrons will be shown by this double-headed arrow. So Y minus negative ion will be formed, which makes it a nucleophile. Nucleophile. And because of that, we'll also have X plus created, and it makes it an electrophile. Now, Y minus, that means the nucleophile, has the ability to donate a pair of electrons, and the electrophile X plus, it has the ability to accept a pair of electrons. For example, in a real life example, let's say we have hydrogen chloride, and we know that the halogen chlorine is much more electronegative than hydrogen. So both the electrons will be taken by the chlorine. Chlorine minus nucleophile will be created, and H plus electrophile will be created. So chlorine minus has the ability to donate a pair of electrons, and H plus has the ability to accept a pair of electrons. Now, homolytic fission occurs when the electronegativity difference of the atoms are very low or basically none. For example, chlorine and chlorine, we have Cl2 at a molecule, so the one chlorine atom is bonded to another chlorine atom. Both are the same atom, so there is basically no electronegativity difference. Now what happens in this case is this bond breaks and each of the chlorine receives one electron, and this electron movement is shown by a single-headed arrow to show that one electron is moving. What happens is, in this case, free radicals are produced. Free radicals are shown by this, and this represents one of the electrons. Now we are producing two chlorine free radicals, so we can just show it like 2Cl. Okay, now what are the free radicals? Free radicals are species that contain one unpaired electron. See this unpaired electron, so this free radical can react with another free radical. We'll talk about it later, right? So in a homolytic fission, the electronegativity difference between the atoms are low or basically none, and the bond actually distributes, the bond is broken in such a way that electrons is distributed equally. Both the atoms receives one of the electron and free radicals are produced. This is how homolytic fission occurs.